Okay, right, so hello everybody and good morning, good afternoon or even good evening depending on where you are. So we'd like to give you a very warm welcome to today's webinar which explores why Geo Internet of Things is the productivity enabler you should probably consider. My name is Christine Durkin and I am your webinar organizer for the day. And for some reason, unfortunately, my slide is not moving. So bear with me 1 second, please. I do apologise. There we go. Shows that this is live and not recorded, which is a good thing. Okay, so I'll start again. My name is Christine Durkin, and I'm your webinar organiser for the day. This webinar is scheduled for around about 45 minutes and with a further 15 minutes or so for answering questions at the end. So throughout the webinar, please do send in your questions via your GoToWebinar control panel and we will collate for our team of experts to address at the end. Also, you'll find 4 handouts to take away in your control panel. So, providing technology works here, I would like to introduce you to the presenters of the day in the form of Hans-Peter Meindl from LTI and Jon Heathcote from Ubisense.
Thanks, Christine. Hopefully you can all hear me. Have you got me there, Christine?
Yep.
Okay, great. Hi, everybody. So my name is Jon Heathcote. I work for Ubisense, and I head up our product management division for our kind of location-aware environments. That's both a combination of hardware and software technologies. And for those of you who've not heard of Ubisense before, we're a leader in the enterprise location intelligence space, where we basically use location as a way to help our customers improve and drive things like quality, cost reduction, improving their productivity and managing things like complexity in this, particularly in the manufacturing and logistics space. Today I'm going to be, as part of this webinar, I'm going to be focusing on our one of our central offerings, which is our location-based Internet of Things platform called SmartSpace. And I'm going to talk about how you can use SmartSpace to bring in location into your organization and use that to improve your overall processes, productivity, cost reduction, and improve quality. Over to you, Hans-Peter.
Give it a minute for the slide to change.
Apologies, I am pressing the button.
Yeah, that's normal. It always works when you do a dress rehearsal.
Yes. Hans-Peter, perhaps you could just speak to your slide whilst I try and get this working. Oh, there we go.
Here we are. Hey, just be a little bit patient. So, hello everyone. Glad that you could make it and join us on this webinar jointly done by Ubisense and LTI. So I'm the one representing LTI on this call. My name is Hans-Peter Meindl. I am the Business Solutions Director for Europe in the IoT space for LTI, which stands for Larsen and Toubro Infotech, which is, despite of its Scandinavian sounding name, an Indian company. And we help our customers mainly in their way to digitization, bring in new digital solutions, new technologies. And as I said, I'm looking into IoT for that. And besides managing, being responsible for the solutions, I'm also responsible for partners. So this is why we are here, why we are doing this together, because Ubisense and LTI are working very closely in the space of Geo IoT and to deliver business value and improvements to our customers. And we are doing this successfully to some of our named accounts, and we would like more of you guys to join us in this journey and to also benefit from the capabilities that we collaboratively bring to the table. So with that, I think we spend enough time on introductions. So it's about time to get into the real stuff. So what I will do now is give a quick overview, quick introduction into this whole topic, and then I will hand it back to Jon, who will, as he already mentioned, go a little bit deeper into the Ubisense offerings, some of the success stories, and then I will round it off again at the end with some ideas around use cases, benefits from this kind of solutions, and hopefully by then we have a lot of questions that Jon and I will then try to answer. Okay, so yes, it is working. So what do we understand by Geo IoT? If we look at the real world and the digital world, then we see one big discrepancy that in the real world you have a lot of objects that are moving around, that are interacting with each other based on those kind of movements that change position, and that is not reflected in your digital environment. So if we look at people or forklifts or other resources like that, they're not stationary, so they move around. And they are in different locations any given point in time. That might be important to improve your processes, to know that, give a reflection back to the guys that are doing your manufacturing engineering, your plant layout, or even help you control your processes better. So quick example is you have that thing that you need to transport material inside your plant, which means you need a few resources. Number one, it's someone that can drive the forklift. You need the forklift, then you have a pallet with material. At one given point in your factory, that needs to go to a different one. So now you need to find the driver. You need to assign the driver to the forklift. By doing that, you need to make sure that the driver is qualified to drive the forklift, and then guide him to the object that he has to pick up, and then ultimately guide him to the drop-off point where this material needs to go. Yeah, you might have the question, isn't there any other way of doing it besides all this Geo IoT technology with tags, etc.? Yes, it is, but it is cumbersome, and we will explain you why we think this whole approach of Geo IoT using positioning systems is the better way of doing it. So ultimately, our goal is to bring whatever you do around your digital twins closer to the capabilities of their physical twins. So if the physical twins are mobile, moving around, we want the digital twins to reflect that in your systems, make that information, that data available for analytics, for controlling processes. Oops. If we look at Geo IoT, then there's a standard kind of categorization starting on the left-hand side with a huge space that needs to be controlled, that can be controlled, all the way down to a workspace, an operation, which is a rather confined space. And on that journey, you have different requirements regarding your precision, the accuracy of your location information. For the sake of this webinar, we will be focusing on site-wide systems, which means we will only look at solutions, implementations that we've done within one production site, one warehouse site, and we will not look at all the others. But if you think you have pressing needs and issues in some of the other areas. You want to track your material all the way from your side to the customer, from your supplier to your location, then we're all happy to have a separate discussion with you and see what we can do in that space for you. So what are we doing there? It is, yeah, the usual approach. It is get to the data in motion faster, enrich the data, which means correlate and enrich with other data, create a contextualized information about the situation, potentially predict a scenario, so what is going to happen, and then start prescribing actions. Due to the nature of this whole beast, this needs to happen rather quickly and very reliably. So I think John will talk about some of the SLAs that we are facing in that respect, but they are pretty tough, and also this whole thing of actioning, alerting is very important, becomes very critical to ultimately reach the benefits that we will touch on at a later stage. So to make this a little bit more understandable, some examples on each of the bullet points that we just mentioned. So if we talk about data collection, then we collect position information. Where is an object, which is mainly information about XYZ axis. So this doesn't tell you too much yet. So this is why we need to do data enrichment, which says, gets in information about what kind of object is that. We look at the individual ID of the object. What is the status of the object? Is there a specific configuration to the object? And many more. Then we contextualize the data. Is the object moving? Which direction is it moving? Are there other objects close by? Is there any kind of relationship to those other objects? So I said, going back to the entry slide, you have the forklift operator and the forklift. So they should get together because you need those two together to start executing. And then we go into predicting scenarios. This can be things like, is this object qualified to be used in this area? Is someone approaching or something approaching an unsafe area? Are there hazardous situations possibly coming up? So look at a warehouse, you have forklifts moving, you have people moving. You don't want those two to get together too closely once they are in motion. And or you want to know about it, and then you want to maybe take some actions. You might want to raise alerts, send information to the forklift driver and said, guys, be careful. There's a person approaching. There might be you want to stop a piece of equipment to work. In a simple case, you have a mobile power tool that is not qualified for that job, so you don't want to workable in this area, etc. Oh, oops, too fast. If we look at technologies that are used in this environment, in this conjunction today, it's the typical IoT scenario. You have a lot of technologies, you have a lot of new technologies coming up, you have existing technologies vanishing, you have a lot of change in there. And as I said, this is typical for IoT. This will not go away. So this is why it is important to be very careful on how you build those solutions, how you start architecturing your solutions. And as you saw earlier, Geo IoT is not just site-wide. It can be on a workspace level, and it can be on a geo level. So you will need different technologies for different use cases. And again, this points us very clearly into the direction that you need something that is capable of taking data coming from various technologies, sensing technologies, that can harmonize this data into a standard kind of format that you can then use in your business systems, being it an ERP system, MES system, PLM, in your analytics and reporting, whatever, and have everything in the same format so it can be digested easily. And this is also then the approach to integrate new technologies, because once you can interface them with this intermediary, this integration platform, all your subsequent systems are still good to go, and they will just use data coming from a new source without potentially even knowing about the new source. And this is why we are totally convinced that you need something that is dedicated and specific to localization, positioning data. And this is why we as LTI decided to work very closely with Ubisense and make Smart Space our integration platform of choice for any Geo IoT related opportunity, and why we are integrating that into our own IP and also looking at enhancing existing IoT platforms coming from GE or PTC, Siemens, others with this functionality. Having said that, I would now like to give it back to Jon to take us in more detail through Smart Space, the capabilities, and some of the experience that customers have with using solutions based on Smart Space.
Thank you, Hans-Peter. Just going to check I've got control so I can go through to the next slide. Great. Okay, so thanks for that intro. So Hans-Peter's touched on this already, but I'm going to reiterate it a bit. We work with customers who have complex manufacturing and logistics environments, and one of the kind of predefining characteristics of those environments are stuff moves around, lots of stuff moves around, and there's a lot of people involved in making those movements happen. And that means that all those things that are physically moving around in the environment, all those people involved in those processes, none of that stuff using standard kind of IoT concepts like plugging a cable in and measuring what it's doing, those just aren't possible. These objects aren't tethered in any way to the business systems that are actually overseeing the processes that are happening down in the real world. So there's this fundamental gap, and there's a lot of data being generated in the real world that business systems just were never designed to even describe, and they have no straightforward way of connecting into. And that's fundamentally what our platform called Smart Space is all about. It's taking, in Hans-Peter's previous slide, all different kinds of sensing technologies, because there's no one sensing technology that's applicable to all use cases, but using lots of different sensors, location and identification sensors, to measure what's happening in the real world and the physical world in terms of where objects are located, how are they moving, how are they interacting with each other. And when through a middleware layer like this, converting all that sensing data into one common language that business systems can easily consume and understand, because these systems were designed 20 years ago, so you need to talk to them in a way that through interfaces and concepts that are already designed into them. And that's exactly where Smart Space comes into its own, in enabling that kind of translation of real-world process into business process at the top level. And we help customers across aerospace, as you can see here, as well as we have a significant presence in the automotive industry, as well as in logistics space. And I'm going to talk to you about examples across all those different industries today. So what are the kind of key business issues and challenges customers have by not knowing the location of all their assets and their products? One of the fundamental challenges is just managing the raw complexity of all of those processes. When you've got lots of moving parts, you've got people using tools to build and interact with products, where those products are changing all the time, so the process a person is implementing at time t is completely different at time t+1. Those variations, that change in complexity, that needing to switch between tasks, that has an immediate impact on things like product quality, ensuring that operators are doing the right thing, error-proofing processes, has a direct impact on product quality, and that has a direct impact on costs, because you can't send something that's not right out the door. So you have significant rework activities associated with products that have quality defects. And when you're trying to manage all that complexity, manage all that rework, manage your costs, you also run into productivity challenges. So these are all quite intertwined, these challenges, and these are the kinds of things that if you start to implement location and identification sensing into your business process, you can start to glean a lot more information about what's happening and actually drive control back into your processes as well. Trying to get the slide to change. So as I mentioned, you've got two worlds basically. You've got business systems and people that really need to know about what's happening down in the physical world, and you've got a very complex end-to-end process. So here we're looking at a typical manufacturing life cycle. This might be a car plant, for example. And you've got moving parts literally from the entrance gate through to the lorries and trains that are actually getting product off site and shipped off to the customer. So we've got inbound logistics challenges where you've got containers full of parts and sub-assemblies coming onto site. They get parked into buffers until they're on time to be docked. Those parts need to get to the dock doors on time because there's a lot of sequencing and scheduling around getting the right parts to the assembly line on time. So you've got unloading challenges, you've got warehouse logistics challenges, shop floor logistics. As I say, getting things to the right place at the right time is a big challenge. And then once you're actually on the assembly line, you've got a massive amount of moving parts, people with tools, so handheld tools, inspection devices, people picking parts. You've got AGVs and logistics trains delivering parts, picking up empties, lots and lots of movements going on. And if you haven't got any way of measuring all this stuff, it's really, really hard to control, and it's really, really hard to optimize. And those movement challenges continue through what's called the offline or the finishing process, and this looks very similar to what an aerospace assembly environment might look like. You've got large footprints, work in progress is moving from step to step, unpredictable challenges in each of those steps. So you might move off into another set of steps. And so if we're talking automotive again, you've got planned inspection steps and rework steps until those products are considered quality assured to get them out the door. And then once you've actually got product that's either ready to be shipped or you're actually storing stuff outside because you haven't got enough space inside, yard management becomes a challenge as well. So there are different location technologies, different sensing technologies you would use in each of these environments to optimize process in this kind of end-to-end cycle. So what are some of the kind of the problem-oriented challenges that you see in each of these environments? And you've got a whole bunch of them really, and you would see a mixture of these in each of these different departments. So one of the fundamental challenges is if you've got physical stuff that needs to be at a particular location at the right time, you've got scheduling challenges. You've got lots of stuff. You need to know where it is to go find it, I need to know if it's actually going to get there on time. You might have a physical distance that it's not possible to cover in the amount of time available. So process scheduling is a real challenge. Visibility of process, and that could be everything from monitoring particular performance KPIs, knowing where your WIP is right now, what status your WIP is in. Are you delayed? Again, that scheduling component comes into it. The ability to break free of kind of rigid assembly paradigms like the fixed workstation on the assembly line and change work cells in a digital way, so you can buy more time for the operator if he's got a more complex process. You can restrict where the operator is allowed to use certain tools and devices in a digital way. Gives you enormous control over processes that were never possible when you relied on real-world controls like tethering on tools and that kind of thing. And that leads directly into process control. You've got lots of people involved in these processes. You want to make sure that people are getting the right information at the right time, and the devices they're using are automatically configured to do the right thing at the right time. So 2 examples here would be handheld tools that operators use to build cars, build tractors. Those tools, if they are being used on lots of different product variations, you want to make sure that as soon as the operator walks up to any product, that tool is configured for the bolts and the batch size and the torque settings required for that particular product. And that might be switching every 40 seconds if you're talking about a high volume assembly line. And you don't want the operator to be responsible for making those configuration changes to the tool. So you can use location to drive changes for devices like that. Another example would be instructions to operators, and that might just be context-aware instructions on worker guidance systems, or it could be inspection displays. The operator walks up to a product with a tablet or some kind of other mobile interface, and for the very specific product they're looking at, the UI changes to show them the steps or the instructions or the quality checks they need to perform at that very time for that product. And there's no reliance on any other manual process to display that information to the operator. Another key use case for continuous improvement activities is just recording all the stuff that's going on. There's a lot of movements, there's a lot of interactions, and if you're not recording it, you haven't got any basis for actually doing analysis of process. So just being able to record it is key. And then you need a way of actually extracting meaning out of all that data. So process analysis is another key challenge and a use case that you want your IoT platform to enable you to do. Process audit, similar to process history and process analysis, but that's about tying all the different pieces of your process together. So an example, if I come back to the tool control, the devices the operators are using, they've got a tool that has to be configured for the right product. You want to know that they're working on any particular product at any point in time. You want to know what the tool was doing while the operator had the tool. How many bolts did he finish? What torque did he finish on? What angle did the tools have? And you want to be able to collate all that data together in one repository so you can get a really, really accurate build record of what happened to each and every vehicle. And again, location and identification of products allows you to tie all those pieces of information together in a reliable way. And one of the really fundamental challenges that everybody has where you've got lots of moving parts is you can't, it's very difficult for humans to record where they've left everything at any point in time. So just having visibility on a map, for example, of where all your stuff is can save an enormous amount of search time and waste in these production processes. So Ubisense enables customers to build solutions with our smart space platform that enable these kinds of problem-oriented features. And we do that with our smart space platform, which is our digital twinning platform technology. And there are a number of different kind of technological features in there. I'm not going to go into too much technology today. but that allow you to create those different use cases that we've discussed. And as Hans-Peter has mentioned, there really are loads of different sensing technologies that you might choose to solve these different types of problems. So Ubisense has their own high precision real-time location system. It's an ultra-wideband based location system, and we've deployed a lot of this into complex real-time control type applications within our customers. But we also integrate lots of other sensing technologies, because sometimes you need a lower cost sensor. Sometimes you don't need the same level of fidelity or real-time response. So we work with customers to choose the technologies that are most appropriate for the problem they're trying to solve. And we even combine technologies together as well, so you get a best of both worlds, like say for example combining RFID with RTLS. So if you want to track lots of small parts, you only track the container that they're all in with an active real-time location tag, and you use RFID to track all the small parts in that container, for example. So as you can see, you can really map different kinds of location-oriented use cases to different departments in the production life cycle. And this is just an example of how those might map, but really everybody's problems tend to be unique. We see kind of core challenges in all these different departments, but most customers want to pick and mix the problems that they are able to solve based on their unique processes. And that comes into working on these kind of IoT related problems in a consultative way with our customers to really understand the details of their unique process. So I'll go into a few of these examples in a little bit more detail, just to give you a bit more of a flavor for the art of the possible. So one of the challenge areas that we see with customers right at the beginning of their production life cycle is just getting parts onto site and to the assembly line on time. Large OEMs, so tractor manufacturers, car manufacturers, aircraft manufacturers, they rely on a complex supply chain for all of their different parts and sub-assemblies that are coming onto site. And there's a significant amount of planning and sequencing that goes into getting these parts to site and available at the very time where a person is going to complete some part of the process and consume those parts or those sub-assemblies. So as always, space is limited on these sites, but they do have areas that they're able to store containers that are coming onto site. So you'll have loads of lorries arriving at all times of the day, and if the parts in those containers aren't needed at that very time, they get stored in parking areas dotted all over the site. And then there'll be tractor or shunt drivers that are responsible to follow a very specific schedule of when those parts need to be docked and unloaded to get them to the right dock door on time. So in order to help in these environments, you need to know where all the containers are, and you need to be able to map shunt or tractor movement activities to the schedule of when these parts are going to be needed. So there's a need to kind of pull all that data together in one coherent way. You need to know where all your containers are, and you can use a combination of sensing technologies to do that. You can use onboard GPS knowledge of the lorries themselves and the shunt tractors that are moving these containers around, and you can infer location from containers using those vehicles themselves, or you can actually tag these containers. It really comes down to what's the best solution for that specific customer. And that gives you knowledge about where these containers are. You also need to be able to import plan information from your planning system and marry that up with the movements that these drivers need to make. You can then forward information to drivers to make sure they're picking up the right containers at the right time, and make sure they've actually docked the container at the right dock door, so that the people inside the warehouse who are driving the forklifts and other materials handling equipment, they're able to get the right parts into the warehouse and off to the shop floor. And once you've actually got parts coming into the warehouse, you want to know how your forklifts and your tugs are moving. Where have you actually stored those parts? Have they gone out of the warehouse on time? So that's where you start bringing in other sensing technologies like real-time location on forklifts, RFID onto your parts, and that gives you a holistic view of where everything is at any point in time. And that means that we can truly solve some of these core challenges in this inbound logistics and materials handling space. So I've mentioned process scheduling, just getting the right container to the right dock door at the right time, getting it unloaded on time, making sure that any other container that's due to be at that dock door, if you've got delays, you can route it to another dock door and everybody knows where that container's been rerouted to. Process visibility, again, just giving real-time live information to anybody about where any delays are in your process. And asset visibility. These guys driving these tractors need to know where to go pick up these containers. So they need a mapping interface that's live on their vehicles and can actually pinpoint to them where they need to go next to pick up their container and what the optimal route is as well. Another example, and I've touched on this a bit already, is in complex assembly processes. Lots of people using handheld tools, handheld devices, picking parts. They need to have a system that's running in the background that enables them to not make errors, that automates some of the configuration changes that are actually happening on the tools and devices that they need to use, so they can get on and action the process that they've been trained to do. And that's how we have used real-time location and other sensing technologies on the assembly line to error-proof a lot of these human-led processes. And that means that we do things like creating digital work cells where for every vehicle that's coming down the line, literally every vehicle in this world of mass customization that we're seeing can be different coming down the line. And that means that operators need variable amounts of time to actually finish processes. The days of the fixed workstation and a fixed amount of time are quickly drying up. And operators need that level of flexibility to enable them to finish their jobs. We've mentioned process control in the form of controlling tool behavior or device behavior. And process visibility is another really key one. If you have processes that are stressed, if you have operators that are unable to finish their jobs, you want to be able to measure all that, those delays and those process overruns, and you want to point out where those stress processes are. You also want to see where your rework is. If you've got an integrated digital or paperless inspection system on your line, you know where your quality errors are on the line. So you want to direct rework activities to wherever they're happening on the assembly line. And that's, again, it's a real-time process visibility application that tells your operators where to go find rework, how much time they've got left to fix any particular quality issue. And if you're able to do that, you can significantly reduce the amount of rework and quality errors that are going into your finishing and offline department. And obviously, again, capturing all this information gives you a much more rigorous process and build audit for your products. So who's actually doing this today? We'll talk a bit more about some customers in a bit, but in terms of being a proven solution, SmartSpace is already used to help produce 5% of cars produced around the globe every year. We're already working closely with 9 of the top 10 automotive manufacturers by volume. So that's a lot of cars produced every year. And outside of the automotive industry, 6 of the top 10 Fortune 500 manufacturers already using Ubisense and have been using Ubisense for over 10 years. So while the Internet of Things market is quickly exploding, this is an industry that we've been working in for quite a long time already. So I'm going to talk you through a couple of more detailed customer examples of how customers have been able to improve productivity and reduce errors in their processes. The first example is a customer of ours in Germany called Hermer. Hermer actually are the manufacturer of large reels of paper labels, and these large reels get fixed to pallets, and they, as you can see from this image here, they all look very similar, and they get stored in a somewhat chaotic fashion. So if you've heard of a chaotic storage warehouse, so it's if you don't have any knowledge about or pre-recording of where all these things are, it's quite easy for them to get misplaced. And when it comes time to actually pull together a customer order, it was quite common for Hermer to actually load the wrong orders onto the wrong truck. They realized, they knew for a long time that there was a significant amount of time waste associated with manually searching for these products, and that was having a knock-on effect for loading productivity. And with no actual guidance for forklift drivers once they'd found the reels, they were basically driving around blind, to both at the pickup stage and in terms of the loading stage. There was no connection between these different stages of the pickup and load process. So customer orders were suffering. I've lost control. There we go. And as I say, sometimes completely the wrong orders were actually getting delivered to customers, and that, as well as cost the business, was having a severe impact on customer satisfaction. So Hermer came to Ubisense, and they presented a key set of business issues and targets and objectives. And an obvious one for them, the one that was the biggest cost center, was just reducing and ideally eliminating loading mistakes, eliminating all that wasted search time, and getting rid of shipping and labor costs associated with all those mistakes. And they firmly believed that they could make a big dent in that. That would also have a knock-on positive effect on their overall process efficiency. It would help to improve their worker motivation, and it would also have a positive effect on environment and job safety. So key requirements to make all this happen: they wanted to make their dispatch area much more flexible. And this is one of the key things we hear from so many customers that are looking to implement location as a productivity enabler. Flexibility is key. The ways that we've been doing things for a long time, they just don't allow you to remain competitive. So you need to be flexible and adaptable, be able to change processes on the fly, and have better knowledge about what's happening on the shop floor. They wanted to be able to create a continuous history of pallet movements and how pallets and product were moving through their process. They wanted to automatically capture zone information. Where is my product right now? How long has it been there? Have I got any aging WIP on site? And they wanted to provide forklift drivers with real-time guidance. Where do I go for this particular order to pick up this product? And where do I take it? Which loading door do I take it to? The system really had to be, it was a production critical system, and high reliability was key. And they wanted to make sure it's seamlessly integrated with their SAP implementation, and it had to be user-friendly for all those who would be using the system. So the solution was a smart space-based solution, and integrated tightly with Hermer's SAP instance. The sensing technology that was deployed was a combination of real-time location and barcoding. So basically the location system would be used to track a barcode scanner, and whenever a pallet was dropped off into the shop floor, a barcode scan event would be related to the location of the scanner at any time, and that would give an accurate location for the pallet at the time of the barcode scan. That would then be used to give, or that information would be fed into Smart Space, where an object and spaces model would record all that information and combine that barcode and real-time location system information together. And that information would then be used to drive user interfaces that were seen by the forklift drivers, and make sure that pallets that were being picked up by forklifts were actually delivered to the right dock doors on time. HERMA had a significant improvement in their storage and loading processes. So they saw a 25% increase in throughput by implementing the solution, a 35% increase in worker efficiency, and as was one of their key and their top target, a 93% reduction in their logistics errors over the first few quarters that the system was running. So who are some of the, aside from implementing the right combination of technologies, what were some of the success factors for HERMA? One of the key things was getting buy-in at the management level, an awareness from everyone at management level that transformation was required. Collaboration and open communication between all members of the team and sponsors in the business, and making sure that everybody who would be using the system had input as to what the final solution would look like, so that they were all invested in it from day one. And this has been a success story for HERMA and an ongoing success story for them. Another example is another one of our customers in Germany called Ortrander. And they cast iron parts for the automotive and domestic appliances industry. Each customer order is unique, so this is this variation concept, and batches flow through a diverse set of fairly nonlinear steps in their manufacturing process. When things aren't actually in process, they're stored in large block storage areas. That helps them to optimize and utilize space better, but it makes finding things and knowing how long they've got WIP sitting in their production process really hard to measure. So they have this inability to record where orders are located and how long they're taking to go through the process. There was a lot of search time waste, and it made planning and forecasting really, really difficult. So they needed a way to automate visibility of this process, and that would allow them to improve productivity and eliminate a lot of the fulfillment delays that they were experiencing. So similar to HERMA, Ortrander really wanted to get rid of wasted search time, and they wanted to reduce the amount of time they were taking to process all these unique customer orders. They also, because they weren't able to get things out the door on time, they were having a lot of fulfillment delays, and they wanted to eliminate that as well. And that as similarly would have a positive effect on things like efficiency and motivation of workers. So HERMA knew that they needed, because of how tough their manufacturing environment was, they needed an industrial robust sensing technology from the get-go to make sure they could actually capture and record the movement of all these parts through their process. They wanted the software, whatever software they chose, to automatically monitor and update the progress and status of these parts as they flowed through their manufacturing process. And they wanted a system for whoever was using it to have an intuitive and easy to use user interface for querying location, quantity, and readiness of any of their customer orders. And just finding stuff had to be much easier for everybody involved in the process. So the final solution was, again, a smart space implementation combining different sensing technologies. So real-time location was used to track forklifts, and on the forklift trucks themselves are RFID readers. RFID tags are fitted onto the different crates and pallets of parts that they're manufacturing, and when the forklift picks one of these up, an association is made between that container and the forklift, and we actually locate the forklift very accurately. So wherever the forklift goes, we know that those parts are moving as well. And by combining different capabilities within Smart Space, we were able to integrate directly into Autranders ERP, and in a cost-effective way, give them this detailed process visibility they were looking for. Oh, back one slide. So there were similar operational benefits. So they had a much more automated way of recording and documenting the positions of all of their work in progress, and the ability to record dwell times, whether they had aging WIP, whether the WIP was flowing through the right set of steps on time, missing steps, all these kind of complex flow-related challenges. They had much more detailed, or have now much more detailed information about what's happening. And they were able to significantly reduce the amount of search time associated with finding all this WIP as well. So that's another success story. And Autrander now have, or on the road to much higher levels of productivity and efficiency, and they have much more detailed information about whether they can do on-time delivery to their customers. And that's overall contributed to making them much more competitive in their industry. So that's a couple of customer examples. I'm going to hand back over to Hans-Peter to talk about benefits at a wider level.
Thanks, John. So let's see whether control is with me. No? Oh, yes. Yeah, let's start off with looking at where we see areas to generate the benefits that we are all looking at. So we already talked, what John talked a lot about, asset tracking, resource optimization, asset monitoring. There's a few others. So you get a lot of additional information out of Geo IoT based system that will enable you to go into sort of a closed loop planning approach, not only with your deliveries and your supply chain, but also with your factory and warehouse layout. As mentioned earlier, if you know how your resources, your objects are moving, for example, through your factory, through your warehouse, you can relate that back to your manufacturing engineering, plant engineering teams that do layout planning based on certain assumptions, which they now all of a sudden can verify, can change, can improve to ensure that the flow is better, is really optimized. Today they get hardly any feedback unless it gets highly critical. So I know about a project ramping up a new warehouse where they had a lot of issues with basically traffic jams on the warehouse flow because forklifts were not moving as planned from a time and also from a direction perspective. And another topic that is becoming more and more important, where we get a lot more requests almost on a daily basis, is the area of safety and security. So this comes from various industries, from, you could say, high-tech all the way to very low-tech. So we're talking to people that are manufacturing pharmaceutical products all the way to companies running large construction sites. And they all come up and said, we want to improve safety and security for our people. So for example, we are now talking about evacuation support systems to provide up-to-date, almost real-time information about where people are in case of an evacuation, is there's still someone in a building, in a room. Where are they? How many are there? Is everyone out? To ensuring that people don't enter into hazardous, dangerous zones on a construction site. That, for example, we are talking to a company that is doing maintenance of railway tracks. So as we can all understand, they try to avoid any incidents between a train and the person working on the site. So you can envision a lot of use cases and benefits out of those use cases in the safety and security space. So we all have to be very creative, and the sort of the sky is the limit. If we look at that, we did a quick brainstorming session with some of our people, some of our customers in various industries, and this is just a snapshot of use cases that popped up because our customers, our prospects see potential benefits in those areas. It's not just in manufacturing, it's also in CPG and retail. It is in healthcare. Interestingly enough, in the meantime, I have more and more discussions with banking and finance and insurance companies. We see that in energy and utilities. You can expand it to engineering and construction, whatever. So I think if we would do a similar brainstorming session with the audience today, we would get a lot of different additional use cases in different industries here. And just to give you some ideas on what is the order of magnitude in efficiency gains. Jon already mentioned some of the examples in quality improvements, safety and security. This is all highly conservative numbers that are backed by discussions with our customers, our prospects, some of the consulting organizations active in those industries. So if you just keep that in mind after this webinar, we talk about real tangible benefits here, and in some areas it's not just the tangible benefits that are of interest. So if you're running let's say something that is in the energy, construction, etc. side, it's also maybe the non-tangible ones. If you don't make it to the headlines with just another accident at one of your sites, someone getting injured, or even fatal accidents, this is also very helpful and very beneficial. So to you as a company, to your market positioning, and Jon mentioned that ultimately it is going to help you to be more competitive, have a competitive advantage over other players in that market. And looking at keeping timing in mind, I would say I would stop it right here. Hopefully we gave you a lot of food for thought on what can be done in this area with this kind of approach, with these kind of solutions. And we would be very happy to go into a more in-depth discussion with each and every one of you to answer your questions, have a detailed look at your specific situation, and come up with some ideas, some suggestions on how to improve that. And as a closing remark, if you look at those examples that Jon presented, in most cases, those projects were the start of a journey to continuously improve operations based on Geo IoT solutions. Thanks a lot.
That's great. Well, thank you so much, Hans-Peter and Jon. Actually, we are receiving quite a few questions here, which is great. You've done a great presentation. So I would like to start off with the first one, and that is, can the system be used on forklifts to pick up a pallet?
I think that question was answered multiple times, especially during Jon's presentation, because in those two use cases, customers are using a lot of forklifts that are equipped with those tags and are integrated in those Geo IoT solutions.
That's great. That's a good comprehensive answer. Thank you. That's the benefit of people who may come in a little bit later on in the actual webinar. Second question we have here: what is typical positioning accuracy of the system?
So I mean, I can jump in there. I mean, that really depends on the sensing technology you decide to use. So with an ultra-wideband based tracking system like the Ubisense real-time location system, you can expect to see anything from 15 to 30 centimeters accuracy, depending on the level of infrastructure you deploy. But as you go into different sensing technologies, your accuracy changes, and that's why you choose the right sensing technology for the problem you're trying to solve. So if you go for something like BLE, you're looking at anything from 1 to kind of 5, even 10 meters accuracy, depending on the complexity of the environment. And when we say complexity, we basically mean how many metallic and reflective surfaces are there in that environment. So there's always this trade-off between the accuracy of the technology you choose and the cost of implementing that technology. But you need to choose the right problem that's going to get you the right return as well for the technology you choose.
Yeah,
that all makes sense. Jon, thank you. Oh, sorry.
Yeah, just one more thing to add on that. We were talking about let's say, the characterization of Geo IoT solutions related to the different size of areas or zones that we monitor. So if we look at site-wide systems, which we said we would be focusing on today, using ultra-wideband as a highly proven, very reliable technology, Jon already mentioned that. If we go one level down and we say we only want to track movements, positioning at one work cell, at one operation, there's technologies available where you can go into probably way below 10 centimeters accuracy for that small space. Commercially, it would make no sense to use the same technology at the next level, which would be the site, or even at a geo level. This would just be, no one's going to be able to fund that. So accuracy on its own is not a virtue. It's something that you need to look at very carefully. What accuracy is required for a specific problem or challenge that you want to resolve? I think we can give you the right solution collaboratively both from a commercial and also from a technology perspective.
Okay, great. I think we've just got time for one more question. We see lots of opportunities to improve production. So how can we get started?
Pick one problem, solve it, and keep in mind that you need to build a solution architecture, a solution approach that allows you to grow. And I think with smart space and the capabilities of smart space, we have something that can be the heart and core of such a program, such a journey, and then we can just pick the one that is the most pressing one or the one that we can solve the quickest so that we can collaboratively show success and quantifiable benefits to justify the next project.
Okay, great. Well, thank you. Thank you all for your questions. If you have any further questions, we are sending out a short survey straight after this webinar. So if you can give us your experience today, and also gives you the opportunity to discuss your needs further. So that just leaves me to say thank you all from Ubisense and LTI teams for attending. Goodbye.